Hey guys, and welcome back to another GCSE Maths Grade 9 exam question. So this question is more probably Grade 8, but we'll include it anyway. It's quite a nice proof question. And we're asked to prove that for all positive values of n, this expression here, so n plus 2 squared minus n plus 1 squared divided by 2n squared plus 3n is equal to 1 over n. So it's a proof question where you don't have to think too much about it. You've just got to sort of follow with the information that you've been given. So we have two squared expressions in the numerator, and we have this quadratic in the denominator. So we have to look at simplifying both the numerator and the denominator here. And let's start with the numerator. So the numerator is a bit more tricky. We have two squared expressions. So n plus 2 squared, so we need to expand that. So if we do that over here, n plus 2 squared. So that's going to be n times n, so n squared. So then it's going to be n times 2, and then 2 times n, so 2n plus 2n, so that's going to be plus 4n. So we're just expanding two brackets here, and then 2 times 2, nice and easy, 4. So that's the first expression squared and simplified. Let's do them n plus 1 now. So n plus 1 all squared. What's that going to give us? So we're going to get n squared again. We're going to get n times 1 and then 1 times n. So n plus n gives me 2n. 2n. And then 1 times 1 is just simply 1. So we've squared both of them expressions now. So let's simplify that numerator line here. So that's going to be n squared plus 4n plus 4. So be very careful now. All these terms now will be minus. So it would be a minus around all of these. So it's going to be minus n squared minus 2n minus 1. So that's the numerator, and this is still 2n squared plus 3n. So now let's clean up this numerator. Let's simplify what we can simplify. So n squared minus n squared, they're just going to cancel. 4n minus 2n, so that will be 2n. So let's start writing this down. So that's going to be 2n, like that. And then 4 minus 1 will just be plus 3, sorry. So plus 3 there. So we've simplified the numerator now, and then this is divided by 2n squared plus 3n. So notice these are pretty similar expressions. 2n plus 3, 2n squared plus 3n. Now we need to end up with 1 divided by n. So this now has turned into an algebraic fraction where we can simplify. So can we do anything with the numerator? Well, we can't do anything with that. It's in its simplest form. Can we do anything with the denominator? Well, yeah, we can factorise, right? So this now, so the numerator will stay the same, 2n plus 3. What about the denominator? Well, we can factorise n out. So n times 2n, and then what do we have to times that by? So that'll be plus 3. So you can see now where this is going. We've got a 2n plus 3 here in the numerator. We have a factor of 2n plus 3 in the denominator. So they're just going to cancel to give me 1 divided by n. And there we go. We have it. We have it in the expression that's required, and we have proven that for all positive values of n by simplifying, this becomes 1 over n. So there we go, guys.